contribution of rainfall in that month to the annual total. So 79.3% of the total annual rainfall is in between June to September. So we can see that this value. And this red dot is representing the interannual standard deviation of each month. And we can see that it increases from April to May. From May to June, it increases somewhat more. After that, it slightly increases to July. After that, it slightly dips down in August. Again, it increases in September, and further it drops down up to December. Now, the same period, 1948 to 2021, in the same IMD dataset, I have divided into two parts, 37 and 37 years, total 74 years I am having. So 37 and 37 years I have divided. So it comes out to be pre-84 and post-84. So this is the blue line is representing the 1948 to 1984 annual cycle climatology. And this is the 1985 to 2021. So we can see that there is a slight decrease in the precipitation in the month of July and August. Otherwise, it's quite similar. Yeah. This one. Now, this is the annual cycle comparison I have made between two reanalysis data, which we generally use, NCEP and ERA5. This region I have chosen as 6.7 to 27.6 north and 69.3 to 90 east. And for ERA5, I have taken 70.5 to 27.5 north and 70 to 90 east. And I'm comparing with the IMD from the same period, 1948 to 2021. And this black line is representing the IMD dataset, annual precipitation, annual cycle of the precipitation, and this red is representing the NCEP. So we can see that NCEP precipitation annual cycle is mostly underestimating from April onwards, but before that it was slightly overestimating the actual precipitation annual cycle. And ERA5, mostly it has overestimated the actual annual cycle slightly, but it is much more close to the observation as compared to the NCEP reanalysis. The next is how the models have captured the annual cycle of Indian rainfall. So there are studies related to AOGCMs, atmospheric oceanic GCM, and how a simple thermodynamical model have captured the seasonal variation of the rainfall. We will see. So this is the first study by Tere et al. 2005, which studies the annual cycle in the syntax global coupled model. So these are the model descriptions, which is shown here. Mostly ECAM, ORCA. ECAM is the atmospheric part and the ORCA is the oceanic part. They are coupled together with this OSS 2.4 coupler and no interactive CIS model here. And simulations are analyzed. Simulations analyzed was integrated for 200 years. And for observations, the zonal and the meridional winds are taken from NCEP Inca reanalysis from the period 1948 to 1998. And area weighted monthly rainfall series of all India 1871 to 1998, the IATM dataset is used for observation of the rainfall. Now, this is the observation, the black color bars representing the observations of the IATM dataset in the given period. And syntax model, they have defined the IMR, the Indian monsoon rainfall in this particular region, that is 75 to 85 east and 10 to 25 north. Only the land points, area weighted average. And is shown in this white bar, that is the syntax model, as you can see. And this is the monthly, how the annual cycle is changing, that is shown here. What we can see first is that in the observation, in the 7th month, that is the July month, is showing the maximum rainfall peak month, which we have seen in the IMD, which I have shown in the IMD dataset as well. So it is matching in the IATM dataset as well. And if you see the syntax model, this maximum rainfall peak month has come in August. So this is one of the differences between the observation and the model which captures the rainfall. And another thing is that during May to September, we can see that there is an underestimation of the model to the actual observation. Whereas after that, that is after September, you can see that the overestimations can be seen. And these overestimations are much higher as compared to that of 1st to 4th, that is January to April. There also overestimations are seen, but not as much as we can see in October, November, and December. Now, why is this happening? For that, they try to show some, they have plotted winds, zonal as well as meridional wind at two levels, 850 as well as 200 hectopascals, the upper level wind as well as the lower level winds. And over the extended Indian monsoon region, 70 to 110 east and 5 to 30 north. So this black is showing the syntax model, the black cubic points, and the white circles are representing the NSET. So what we can see is that from 5 to 9, if you see here, the model has underestimated the rainfall, the zonal winds at 850 hectopascals, and you can see that it has overestimated the zonal wind at 850 hectopascals, because you can see that these are the negative values, and it has given more negative as compared to that of the observations, both here as well as here. Same thing can be seen at 200 hectopascals, where again this particular region, if you see, stronger negative winds are seen in the observation, but it has captured weaker. Whereas in the other months, like October to December as well as first to fourth month, it has overestimated the actual zonal winds. Same can be seen in the meridional winds as well. But another important thing is that over the zonal winds, when seen over the equatorial Indian Ocean, there is a complete mismatch. You can see in the October from September onwards with the observation and the syntax model. Whereas in the 200 hectopascals, if you can see here, we can see that from April to July, there is a sudden transition from -8 meter per second to -22 meter per second because of the increase in the upper level northeasterlies in the equatorial Indian Ocean region. But model have captured it, but with a very weaker magnitude. So what is happening in the observations which are known to us, that is stronger latent heat release associated with Asian monsoon, it strengthens the upper branch of the Hadley cell. On the other hand, active convection center is far away from the equator, so Coriolis acceleration is much more effective in accelerating the upper level northeasterlies. And model captures it, but with a very weaker amplitude. This might be the possible reason why syntax model have given underestimated, particularly during the monsoon period. Now, another study by Crater et al. 2016 with the same syntax F2, but now ECAM 5.3 instead of ECAM 4 is used, and NEMO model is used. I am not going to the model descriptions, but these are the experiments they have done, and some observations from that I have just taken out. So this is the observation rainfall is that all India rainfall Parthasarathy 1995, the IITM data, and the Indian rainfall in the syntax model is taken as the land points between 5 to 25 north and 70 to 95 east. Now, several experiments are done. Actually, they're trying to study without ENSO, IOD-ISM relationship, but from there they have shown that what will be the mean annual cycle and international variability. So that I have taken. So the control experiment is that 210 years integrated carbon model experiment. FTPC is 110 years integrations, which is similar to the control, but except over the tropical Pacific region only, the SSTs are nudged to SST climatology of the control. Whereas in FTPC observations, it is 50-year integration similar to control, except over the tropical Pacific area, the SSTs are now nudged to the SST climatology of the observations. That is the daily optimal interpolated ABHRR B2 SST 1982 to 2010. Now, nudging used in FTPC and FTPC observations actually modifies the non-solar heat fluxes in the tropical Pacific through a correction term, and scaling with the model error that completely removes the ENSO scale variability. Therefore, FTPC and FTPC observations are non-ENSO, and CTL is having ENSO-ISM relationship well established. Now, what we can see here is that this is the observation of the mean annual cycle. This is the observation, the IITM data. But if you see the control FTPC and FTPC observation, which is having one with ENSO, and this is without ENSO, not much changes in the annual cycle can be seen. Particularly if you see the control, again it has picked the that August as the maximum rainfall peak month, but it has improved. This FTPC observation by nudging the SSTs to the observational SST climatology, we can see that this has improved and it has captured the maximum rainfall peak month correctly over July. But intensity wise, all the things are very down to that of the observation. Now, another important thing I want to show that this interannual variability of all these things, where it has been observed that this FTPC observation has enhanced the interannual variability has increased during the month of June. So in the month of June means the ISM onset rainfall variability will be enhanced in the non-ENSO experiment. The reason for that is not much given in that paper. They have discussed more about the IOD-ISM relationship in that without ENSO and with ENSO. So just I wanted to show these two figures. Another study by Professor JS about a simple thermodynamical model, which is based on the energy and the moisture budget equations, both combining both with certain assumptions that omega profile should be this and constant temperature last in the tropical atmosphere, and weak temperature gradient approximation is used in the tropics. So based on this, both the equations are simplified to become this, that precipitation is related to evaporation plus Q net, the net energy at the top of the atmosphere, and divided by delta minus 1. Delta is this particular integral. Now delta when is compared or scattered plotted with this P watt, we are seeing that this is the scatter plot, and fitting this scatter plot, we can see that this red line actually fits this particular scatter plot quite well, and that is showing a kind of a rectangular hyperbolic relationship, that is delta is equal to C by PW, and C is calculated to be about 85. Now putting these values in this equation, that over the Indian region I have just taken, the study takes place in different regions as well. But over the Indian land, this is the simple model, this particular based on particular equation, and this is by this white dots, and observation is this black dots. So it is compared with the observations. What we can see is that the peak month, the maximum rainfall peak month has well captured, and certain months also it has captured the observations quite well. But in 87 as well as 86, there are 7 months where it has overestimated the actual observations. So these are the modeling studies or the models, how the models have captured the annual cycle of the Indian rainfall. The next is the simplified projected changes in the annual cycle of rainfall. I have taken 2 studies where in both the cases, the highest concentration pathway RCP 8.5 is taken. That is by 2100, the net radiative forcing will be 8.5 watts per meter square. Before that, Giannini 2010, while studying over the African or Sahel region, they devised 2 mechanisms. One is the local mechanism and another is the remote mechanism related to the precipitation changes over the continents due to anthropogenic forces. So one condition is that it will increase in the future due to anthropogenic forcing, or it will decrease. So increase is given by this local mechanism, and this decrement in the rainfall is given by this remote mechanism. So local mechanism states that if there is sufficient moisture due to anthropogenic forcing, if there is sufficient moisture and increased downwind radiation will result into increase in evaporation, will further increase the low level moisture decay, decrease the stability of the atmosphere, and there will be increase in rainfall. Further, if there are more moisture convergence over the continental region, that will further reinforce the rainfall to increase over that continental region. And for the decreasing mechanism, this is the remote mechanism. It starts with actually when there is a warm SST, that will lead to large-scale tropospheric warming. That will lead to continents where moisture is less, and that results into reduction in the precipitation. And if evaporation is also less, that will further reduce the precipitation. So these are the 2 mechanisms, local and remote mechanism, that is related to, one related to the increase in the rainfall due to anthropogenic forcing. Another is related to the decrease in the rainfall due to anthropogenic forcings. Now, these 2 mechanisms are actually used to explain this particular study by Anjali Seth et al. 2013, where 17 semi-5 models are used, and the multi-model ensemble being they have taken and for the entire study. So this study is particularly focused on what will be the semi-5 projections of the annual cycle of the precipitation over different monsoon regions. I have taken one of the South Asian monsoon regions because I'm talking about the Indian part. So over the South Asian monsoon region, I have compared, they have compared during the historical minus CMAP in the period of 1982 to 2005. What we can see is that models have not captured the precipitation correctly. It's much more drier in the beginning, and after that it has increased. Whereas CMAP precipitation is this, the contours, which is present here. But still, this 1775 multi-model ensemble beam is still used for the study. So now onwards, the historical time period will be 1970 to 2000. RCP 8.5 will be 2070 to 2100, the last 30 years of the centuries. And over the South Asian domain, like 65 to 85 east and 10 to 25 north, they have averaged the longitude 65 to 85 east in each and every diagram. So it will be a latitude month ocular plot. This is now this particular figure is now the precipitation RCP 8.5 minus historical. So this is the shaded portion is nothing but the precipitation at RCP 8.5 minus precipitation at historical. And for comparing purpose, because with respect to historical, it is everything is seen. So this precipitation contours are actually representing the historical precipitation contours. Now, what we can see is that from January to up to May or June, starting of the June, we can see that there is a decrease in the rainfall in the RCP 8.5 with respect to historical. And there is an increase in the precipitation from June onwards, so June or July onwards, in the RCP 8.5 with respect to the historical. Its corresponding energetic framework, they have used a grad MSE, which is MSE 200 minus MSE 850, that is MSE at the upper level minus MSE at the lower level, 850 hectopascals. So this grad MSE, if it is positive, that means a stable condition. If it is negative, it is an unstable condition. Now, this same grad MSE is taken for RCP 8.5 minus grad MSE of historical is shaded over this the lower diagram, which I am showing right now. So what we can see is that from January to April, we can see that these regions have a positive values of grad MSE in the RCP 8.5 with respect to historical. That means, which is going with this particular thing, that if there is a decrease in the precipitation, in that case, the grad MSE over this region in the RCP 8.5 scenario, it is increased. But after that, from April, May, and June, although the precipitation is still decreased over here, but this grad MSE is showing that there is a negative, some negative values of grad MSE in RCP 8.5 with respect to historical. I will come why this is happening. And after that, after June onwards, we can see that several strong negative value patches can be seen over different regions. That means that grad MSE is much more negative, so much more unstable atmosphere can be seen over these areas. Now, not only that, the grad MSE part they have shown, they have also evaluated the moisture budget terms. So over the South Asian region, the divergence, moisture divergence is a positive one. So divergence at RCP 8.5 minus divergence at historically shaded over this particular region, where we can see that January to June, there is a strong moisture divergence. After that, the strong moisture convergence starts building up over this particular time and over those regions. On the other hand, evaporation has not decreased, rather it has increased in all the months over this particular region in the RCP 8.5 minus historical, whereas relative humidity also have not changed much, except for above 30 degrees north, means north of 30 degrees north. Whereas in the later part of the monsoon season through up to November, we can see that there is an increase in the relative humidity over this particular region. Now, based on all these observations, we can explain the entire thing through this particular diagram. So in the dry season, first of all, this is the temperature profile. This one is for the historical. This is for the RCP 8.5 in all the cases. And this is the upper level, the MSE actually, because delta MSE, because moisture is not much in the upper level. And this is the lower level, delta MSE. Delta MSE means MSE at RCP 8.5 minus historical. That's why they are given data. So for the dry season, we can see that there is a deficit low level MSE, which we have seen in the grad MSE plot also, which is positive. So because of that, this is a stable atmosphere, and because of that, there is a decrease in the rainfall, which we have seen from January to April. There is a reduction in the rainfall in the RCP 8.5 with respect to historical. Whereas in the transition season, what is happening is that there is an increase in the delta MSE. If you observe this and this, there is somewhat increase in the delta MSE, but delta LQ, the moisture is low. Delta LQ still remains the same almost, but delta DAC has increased with respect to this. Therefore, what we have seen in the transition months from April to June, here, these negative values are actually because of the change in the temperature over this particular region, not because of the moisture, because moisture convergence is not there. It's completely divergence in April, May, June, the transition seasons. Now, after the transition season, if you go to the enhanced rainy season, we can see that the delta MSC, change in MSC has increased much more as compared to any of these two values. So increased low level MSC will result into, and we have seen that delta LQ also has increased with respect to any of these two terms. Delta LQ has also increased because of the strong moisture convergence. So this serves the local mechanism to trigger, and that will result into increase in rainfall in the RCP 8.5 scenario. Whereas in the dry season, this deficit low level MSC results into a stable atmosphere, and that results into reduction in rainfall, which is associated with the remote mechanism. After that, this is the last study which I have taken by Jenner et al. 2016, where the 20 semi-5 models, individual models performance is seen, not the multi-model mean. And 3 periods, historical period is same as the observation, 1871 to 2005. And RCP 8.5 is taken, unlike the other case, it is a long period from 2006 to 2100 period, it is taken. Now, this is the maximum rainfall peak month count. So if this is the observation, this red color graph is observation. So out of 135 years, from 1871 to 2005, out of 135 years, it has shown that 109 times it has occurred over July, and others it has occurred over August. All the models are all the models and its performance is seen over this particular graph, which is very difficult to visualize each and every model. But they have seen that 9 models out of 20 simplified models have captured the observation peak maximum rainfall peak month counts, and these are these models. Now, another thing is that this is the average rainfall annual cycle. So we can see that this is the observation which peaks at July. That is fine. IITM data is only used here, and after that it decreases, which we have seen on those things. All the models annual cycles are drawn. And it has been found out that 7 models out of 20 have captured close to the observation annual cycle. So combining these two properties, those models which have captured the observation closely are the MIROC-5, MIROC-ESM, and MIROC-ESM-CHEM, these 3 models. And these 3 models, when projected, it projects a reduction in the average intensity of all India annual cycle by the end of 21st century. So this is the result they have just written, they have not shown with any figures, and ultimately concluding all those things. So how the models have captured these two studies, the AOGCs have captured the annual cycle. These 2 studies shows that, and it couldn't capture the zonal and meridional wind, or it captured the weak. It captures it very weakly during the summer and overestimates during the winter. That's why model has not captured or underestimated the observation during the MJJX period, and after that it has overestimated. And created in 2016 particularly shows that this non-ENSO experiment, in the non-ENSO experiment, when the SST over the tropical Pacific is nudged towards the observation SST, it has been seen that the interannual rainfall variation in June has increased. And Srinivasan 2001 have shown that using energy and moisture budget equations and several approximations, 3 approximations using that, a simple thermodynamical model. It actually captures the seasonal variation quite well over the Indian land, captures the peak month quite well, but overestimates in some particular months. And semi-5 projections in SET et al. 2013 have shown that using the multi-model ensemble mean of 17 models, that there is an increase in the precipitation during the monsoon season, and during the dry season there is a decrease, and those can be associated with the local and the remote mechanism respectively. And Jenner et al. 2016 have shown that models that have performed well in capturing the intensity of the annual cycle and the peak count of the maximum rainfall peak month, it shows a reduction in the rainfall intensity by 2001. So by this I will end. Thank you.
Yeah, electric rainfall is winter, but related to western disturbance. Do they talk about it?
No. No, they have not
looking at. I'm not going to talk about it. I mean, nothing tropical, something coming from mid latitude. So that is a bit surprising. I'm not seeing, maybe we should look at. So that's surprising that it will have a big effect on winter monsoon and agriculture. Right?
Yes.
All the rainfall, but Haryana and winter comes from. If that is true, really useful, that is a serious issue. Thank you.